your attendance here today. Welcome to Concurrent Section 3, Early Detection and Rapid Response Eradication. Before we start, I just want to say my name is Brandon Williamson, and I'll be your moderator for the next three speakers. Just want to thank the gold sponsors today, City of Toronto. Silver sponsors will be the Invasive Species Center, Evolutionary Vegetation Management, and the Toronto Region Conservation Authority, as well as CPRO. And our bronze sponsors, BASF and Corteva Agriscience. Excellent. So with that, the first topic today is using AI and drone technology for early detection and aquatic invasive species. I'd like to introduce our speaker, Matt Boulding, Invasive Species Program Coordinator for Ducks Unlimited Canada. Matt Boulding is the Invasive Species Program Coordinator for Ducks Unlimited Canada in Ontario. In his role, Matt leads the management of European water chestnut populations on Wolfe Island, spearheads DUC's AI-driven drone surveillance program for aquatic invasive species, and collaborates on biocontrol research for invasive Phragmites australis. Additionally, he serves as the Eastern Regional Coordinator of the Ontario Phragmites Action Program. Trained as a wetland ecologist, Matthew previously worked at the University of Waterloo, where he contributed to research and monitoring efforts for Phragmites management in Long Point, Ontario. His work reflects a strong commitment to innovative and collaborative approaches in the fight against invasive species in Ontario's wetlands. So with that, I'll turn it over to Matt Boulding. Thank you.
Thanks. Let me get my screen share going here.
I'll give you about a 3-minute warning towards the end, Matt.
Sure. Can you see my screen?
We can see the screen, just not presenter mode.
Oh, okay.
It's there now. It was.
Sorry, there we go. Okay.
Perfect. Thanks.
Awesome. Thank you. Yeah, so thanks everyone for attending. I'm going to talk about using AI and drone tech for the detection of aquatic invasive species. I'm going to just sort of start by giving a quick overview of the challenges of invasive species detection, which I think we're all pretty familiar with. And then talk about our European water chestnut program and how that led us to incorporating drones, which led us to the incorporation of AI technology. And then speak about how we're sort of moving this drone program to include other species, specifically water soldier. Also, I tend to ramble, so I want to make sure at the jump, I acknowledge some of our key partners, the Green Shovels Collaborative in association with the Invasive Species Center. The Ontario Ministry of Natural Resources have been huge funding partners on all of this work. Sewa is an AI software company that did the AI portion, which is a sort of computer magic that I don't understand completely. And huge thanks to Parks Canada and the Ontario Federation of Anglers and Hunters for providing us with insight and study sites and imagery. And there's lots of other folks involved, but I just wanted to make sure I get that at the beginning. Okay, so we're all familiar with invasive species. We all know that there's a lot of challenges to catching an invasion early before you get these huge populations that are really sort of distinct and characteristic. And those challenges there's a lot of them. It's really easy to sort of miss sort of small individuals or small sparse populations, and capacity limitations are kind of one of the bigger ones. Having enough funding and enough staff time and the ability to kind of go out and do surveys on the water or in the forest on the ground to find these invasive species, especially if they're in sparse or remote locations, they can be missed. As a lot of people have talked about already today, we often, really a key important tool in finding invasive species is sort of utilizing the general public. But there are knowledge gaps, especially with newer invasives. Even with well-established invasives like Phragmites, there's lots of people in the general public who don't know that this tall plant is something you should be worried about. Ultimately, I feel that the best way to find invasive species is to do on the ground or on the water surveys. But as I said, that's not always feasible because it's pricey. And through our work, I found that drones actually have a really good niche to fill in this sort of their ability to do a very quick pass, like a timely survey of an area that you can process relatively quickly. And they might be able to help you find, if not all invasives, at least some invasive species. So I'm going to talk about our European water chestnut program and how that got us to drones. Very briefly, European water chestnut is a floating aquatic invasive plant that was introduced to the US as an ornamental plant in the late 1800s from Europe, Asia, over in the old country. It has this very distinct leaf rosette pattern as the leaves float on the water. And it was first observed in Ontario in 2005. It also drops these really gnarly little caltrop seeds that you don't want to step on. Like a lot of invasive species, it really hits all those marks. It grows really quickly, forms these really dense mats that outcompete native plants, which in turn lead to lower oxygen levels and negative impacts on habitat for fish, waterfowl, and other wildlife. It also impedes navigational waterways and recreational use of water. And like I said, it drops nasty little seeds that you can step on. So Ducks Unlimited Canada got involved with water chestnut back in 2014. And since then, we've been managing a population on on Wolfe Island, which is across from Kingston in the St. Lawrence. There are 3 bays that we've been hand pulling water chestnut at, Bayfield and Button Bay, starting in 2014. And we included Lewis Bay in 2017 when chestnut was found there. And our approach was what I call an integrated monitoring and management approach. And by that, I just mean the folks on the boat who were hand pulling water chestnut were looking for it at the same time. So they would boat around and they would see a plant and they would pull it out. It's slow going, but it's an effective method for control. And this used to take about 25 or 30 days. As we jump ahead a few years to 2020, 2021-ish, technology has become a little more accessible, specifically with drones. And we started to think, hey, water chestnut looks really distinct when you look at it from above, from a drone's eye view. Maybe we can use drones to expedite that sort of surveillance process and save a bit of time on the water. So we started with a real entry-level drone, like a drone that you could go out and buy as a person very easily, a DJI Mavic Mini 2. Takes pretty standard photos, easy to use, and we used that to capture imagery of the bays to try and identify plants. And image collection's really fast compared to doing on-the-ground surveys. You can stand on the shore if you're in the right location and fly a whole bay in like an hour, less than that. It's really easy. But you get a lot of images, and those images can be really busy. And there's a lot of like this image, for example, was taken this last summer at Bayfield Bay. There's a lot of plants in here. There is a little bit of water chestnut, but you got to look through it. It takes time. And in fact, we found that if you were doing a full day of sort of field collection with the drone, you're collecting about 1,500 separate images. And manual analysis of images were about, on average, like 2 minutes per image. It's a slow process. And we were thinking, it's got to be a faster way, right? And like I said, technology is improving. So we turned to AI. We partnered with Sewa, which is an AI software company that created, and I cannot speak to how the AI tool functions. It is computer magic beyond my abilities to understand. But they created an AI-driven tool that will scan the photos and will identify that distinct leaf rosette of European water chestnut and mark it. So by 2023, we had multiple years worth of imagery, at least 2 years worth of imagery that we were able to feed into the software and train it. And the result was this easy to use program. Essentially, we would go out, spend a day or two, depending on how big the area we're surveying, to collect these images. They would be fed into this AI tool in a very easy interface. And then the tool would scan the images for European water chestnut and output them as a spreadsheet with lat-long coordinates that can be transferred to a handheld GPS unit and given to our managers on the water. The tool was super effective. And I wanted to highlight that it allows for you to go through and curate the results. So you can go and look and see what it's flagged as water chestnut and be like, yes, that looks correct, or no, that doesn't look correct at all. And that, in effect, further trains the tool and improves it for later use. So this past summer, we deployed the tool to help our management efforts. The map on the left is the plants that were identified through the drone and the AI tool, and the map on the right is the GPS points taken by the folks on the boat actually physically pulling the plants. And they do line up fairly well. The technician who's been doing our water chestnut management has been doing this for a few years now, and did remark that it actually made his job a lot more efficient. He knew where to go to begin to look, and it would expedite his surveillance process. There were some misses. Obviously, we're not going to catch everything. There's some time lag between when we fly and when the management starts. So plants could emerge, or there could be other floating vegetation that obscures it, or even emergent vegetation if it's close to the cattails. And there were some false positives. So sometimes European frogbit or damaged water lilies would be interpreted as being water chestnut. But on the whole, the AI tool has about a 93% accuracy rate. So 93% of the water chestnut that's caught in our drone photos can be identified by the tool. And it really did help expedite our work time on the water down to about 10 days, 3 of that being the time that we actually took to collect and process the images. So with that as a sort of a real positive result for us, we began to look at other species that we could use a similar approach with. And the first one that came to mind was water soldier, which is well established in Ontario at this point. Unfortunately, it's in the Trent River and Lake Simcoe, but it does have kind of a distinct morphology. If you look at water soldier from sort of the drone's eye view from the top down, it kind of looks like a pineapple, that sort of crown of a pineapple. And we thought, hey, this is a great direction to head into. Water soldier presents a couple of additional challenges. Whereas water chestnut floats, water soldier is often submerged, so you need to get imagery of a plant under the water. So water clarity is a factor, and weather always plays a role with drone imagery, but even a slight breeze can create ripples on the water, which could obscure our collection of a submerged plant. So this past summer, we started with a known located population working with OFAH and the Cataraqui CA. We went to Red Horse Lake, which is right beside Charleston Lake Provincial Park. And we met up with some technicians who had already done surveys there and had found a known population. And we were able to then sort of go to the spot and just take an afternoon and calibrate our drone to be able to try and visually pick up water soldiers, sort of try different speeds and different heights and different polarized filters to help us see underwater. And the result, not sure how clear this is going to be on your screens, but in this red sort of ellipse, you can see, hopefully, there's these 2 sort of greenish blobs that have a lot of little black dots in them. Those would be the center of the crown of the water soldier leaves. So we were able to see water soldier in our imagery, which was excellent. So from there, we moved to a location where water soldier was known to occur, but it wasn't mapped. There was no GPS point saying, go here to look at water soldier. This was Cook's Bay on Lake Simcoe. And this, we flew here not really knowing where we were looking, other than that we were in the general area. And once again, we were able to detect a number of populations of water soldiers. Just to zoom in a bit, again, you can see that kind of blob with those little black dots. It's pretty distinct. And this was very, I mean, it wasn't exciting to know that there was this water soldier there, but it was exciting to know that the drone was able to find it. And this is a great example of flying a drone over an area where maybe you think invasive water soldier is, and then being able to detect it through the drone. This is maybe an extreme example because it's a pretty established case, but it's still kind of a proof of concept. Taking this imagery and imagery that we were given from folks at Parks Canada and other imagery we collected, we of course have given this back to SEWA, our AI software development team, where they are working to adapt our chestnut tool to be able to automatically detect and GPS mark plants from our water soldier imagery. I think this past year, with all the imagery that we got from Parks Canada and our own imagery, they're looking at about 2,600 images that were fed into the tool as both a training, validation, and test different sets. And they're seeing about a 95% accuracy rating for being able to locate and sort of mark water soldier. So that's really super exciting for us, and we hope to go forward into this this coming summer to collect a lot more imagery and begin to kind of implement the tool as a way to map water soldier populations that we're finding. Okay, so just to summarize, we have been using drones and the AI auto detection tool, and we have found them to be pretty effective for European water chestnut, and they're showing great promise for water soldier. So this is allows us to sort of decrease our surveillance times, leading to a more efficient management effort. But it also creates the potential for a quick pass, as I call it, to sort of scan an area for these two species. I think a couple of folks have already remarked today that there's one of the big challenges of monitoring and surveillance is time on the water, getting staff, getting out there on boats or whatever the case is. But if you're in the area, it's pretty quick to capture drone imagery. You can take an hour, maybe, depending on the range you have to cover. And then it's just a matter of processing the imagery and running it through the tool, which is mostly hands-off, honestly. The limitation, of course, is that AI auto detection is really focused on conspicuous plants that will be distinct from the drone. So right now, things like water soldier and water chestnut are pretty distinct. There is potential for some other species that we're looking into, like flowering rush, but that's still very preliminary. Then you have things like Phragmites, where you can easily notice it in a drone, but you'll never be able to parse invasive and native frag. Not that that's often an issue, but it's something to be aware of. And then you have real limitations with cryptic invasive species, or ones that are very distinct on a small level, like hydrilla. It's easy to notice a large mass of submerged aquatic vegetation, but the drone will never have the resolution to sort of tease out what exactly is in there. But I see a great potential here for drones and AI to kind of really help on a few target species, just a quick pass. And the technology is becoming a lot cheaper and more accessible, which is awesome. So with that, I'll open it up to any questions.
Thank you very much, Matt. Appreciate it. Amazing presentation. Again, we do have a few questions here. We've got about 4 minutes. Can we use drones to deliver targeted herbicide to isolated Phragmites stands and wetlands? Obviously, something I'm interested in as well, but I think most of us are. But
so I think, and I'm not the one to ask about this, that would be Janice Gilbert from IPCC. But my understanding is that has been trialed. I think you can do that in the US. It's being trialed at a research basis so far in Ontario. And I think it's going to be approved for drone delivery relatively soon. But again, not the one I'm not the one to ask about it. But yeah, I think that's going to be something that'll be available relatively.
And I know drone piloting has just been sort of opened up by the government as well recently, so that may change that. So is there any research on how drones could impact water birds within the bays? Or have you heard of that?
Oh, that is a great question. I don't know. That is actually something to look into for sure. We tend to fly at about 30 meters for our drone imagery collection, which is pretty high. I do observe some birds being flushed, but it's always hard to tell if it's because the drone, when it gets up high, it is pretty quiet. So I don't know. That's a great question. That's something to look into for sure.
Yeah, definitely. I'll just ask one more, and then there's a couple more in the Q&A if you have a chance to stop in there. But the next question we'll ask is, how does the AI software output coordinates from the photo input? In other words, are the drone photos geo-referenced?
Yeah. So the drone, again, I'm not the GIS lead at Ducks. We don't do like ground truthing or ground control points, but the drone has its own GPS in it. And so we end up taking all the drone photos and making an ortho mosaic. So there are Like there is spatial data in the imagery. So that spatial data is the tool can read that and will output as a GPS coordinate based on the drone's GPS. There is an inaccuracy there, but what we found is for a floating plant, they're moving a little bit anyway, so that plus or minus a few meters isn't that much of a detriment.
Right. That's great. Thank you, Matt. I really appreciate it. Thank you very much for your time today and your presentation. And again, if you have a chance to pop into the chat or the Q&A and just answer those questions, that'd be great. Thank you very much.
Sure.
Okay, so we'll move on to the next presentation. While it's being brought up here, it is European Frogbit Collaborative, Improving Coordination of Early Detection, Monitoring, and Management. So I would like to welcome our speaker, Samantha Tank from the Great Lakes Commission. Sam works as a program manager overseeing the Great Lakes Commission's Aquatic Invasive Species Program. In this role, she coordinates the Great Lakes Panel on Aquatic Nuisance Species and various invasive species collaboratives, including the Great Lakes Phragmites Collaborative and the Phragmites Adaptive Management Framework, the Invasive Mussel Collaborative, and the European Frogbit Collaborative. So with that, Samantha, welcome and take it away. I will give you about a 3-minute warning at the end. Thank you.
Great. Thanks so much, Brandon. And yeah, lots of collaboratives in there. So today I'm going to be talking about the European Frogbit Collaborative. So I'm really excited to share this with you. We have a lot of really great tools for all of you out there who are working with or monitoring or even trying to get started with management of European Frogbit. I know that this is pretty widespread in Ontario, and it's something that we're really trying to get good regional Great Lakes coordination on. So I'm really excited to talk to you about this today. I guess I'll just really quickly acknowledge those who have helped support the work I'm going to talk about. So Taja Tucker Silva and Nicole Angel with me at the Great Lakes Commission, and then Billy Kuiper at Michigan Environment, Great Lakes and Energy. So what is European Frogbit? Well, it is a free-floating aquatic plant. And so the kind of main identifying factors of it is it's going to be free-floating. It does have these rootlets, but it's going to be floating on the surface. It has these fine root hairs. So if you picked one up, you're going to see these little rootlets coming off of it. The leaves are pretty small. They're heart-shaped. And instead of if you looked at like a fragrant lily, they're going to be more pointed. This one's a more rounded lobed edge, pretty small, 1.5 to 5.5 centimeters roughly. The flower is pretty distinct. So it's a white flower with 3 petals on it. And honestly, we're having a hard time nailing down when it is sexually reproductive. So the flowers seem to appear sometime between June and August, but that changes so much between years. So they can produce sexually, but they also can have some asexual reproduction. So they have stems, stolons, and so these are kind of horizontal runners in which they can produce new plants. And so this is what that would look like. And they also have asexual reproduction through turions, which are these kind of like seed pods that they drop, and then they will emerge the next year. And so really, if you're going to do any management of this plant, you want to do it before they drop those turions, because they can live dormant in the aquatic soil for quite some time. And this is what the turions look like when they develop. So when you see European frogbit, even though it's a relatively small plant, it forms these dense mats. And so you're unlikely to just see a couple plants. If it's a new invasion, maybe that's going to be the case, but this is what it looks like. And you can see it likes to grow around plants that look pretty similar to it. And so that can make ID a little bit challenging, but this main distinguishing features, like I said, this is right here is a fragrant water lily, and you can see the pointed leaves instead of the rounded lobes like frogbit has. And then here's some duckweed growing around in it. But they like similar habitats, so where are you going to find this? You're going to find it right around some other aquatic invasive species like Phragmites, or a lot of times around cattail. So it really likes calm, slow-moving waters. Since it is floating, it just kind of goes where the wind and the waves take it. And so low exposure areas, sheltered, that's where you're going to find it. It really likes to get back into kind of these highly vegetated areas too, which, as you can imagine, makes monitoring and subsequent management activities really difficult. So how it got here, it was brought over to Canada probably sometime around the 1930s as an ornamental plant, and then escaped into a canal and led to Great Lakes introduction. So it's been around for quite some time, but it's really making a lot of moves lately, unfortunately. And so it's spread from the eastern part of the Great Lakes, and now we're finding it all the way on the western side of Lake Michigan. So like I said, it kind of moves where the waves take it. So in open water bodies, it's going to be just kind of pushed around, taken with either currents or waves. But it's also transported a lot of times by people, like most aquatic invasive species. So boating, you can see that there's some frog bit wrapped up right here in the prop of this boat. Also hunting activities as well, especially waterfowl hunting. So same things, boats, equipment, these are ways to carry it around. There's also some concerns that it can get, since they do drop these turions in places where you're potentially walking in more like ephemeral areas, that those turions could be transferred in like the treads of shoes or other ways. And then wildlife. Potentially birds moving it around, other wildlife. That's a little bit more of a question mark at this point. So those dense mats are obviously not good to promote native growth. You can see this is a couple of folks trying to actually do some manual removal, and it's not easy. You can get many tons of this biomass in a pretty small area that you have to get rid of. So it does cause habitat degradation, really difficult to get through here if you're trying to boat or swim. So definitely impacts on recreation. And then it does cause anoxic conditions or annual die-offs as well, because it does really bring down the oxygen level in the water bodies that it's in. So now kind of just moving on to the collaborative. So this was an effort that was started in Michigan in 2018. And so we are fortunate enough in the States to have Great Lakes Restoration Initiative funding. And so from the beginning, the collaborative was Great Lakes Restoration Initiative supported, but it really became apparent that this was an issue outside of Michigan pretty quickly. And so the Great Lakes Commission, where I'm working out of, was approached I think sometime in 2020, and then in 2021, we started conversations about being the neutral backbone organization and expanding the collaborative. And so then in October of 2022, we received our first round of funding to do just that. And so the European Frogbit Collaborative, which I'll put it up here a couple more times, but if you have a chance, I would encourage everyone to check out our webpage. Lots of good resources that you can find all the stuff I'm about to talk about at. So the collaborative is really meant to be a collective effort that is representative of all of the Great Lakes region. And so we're not just limited to the basin boundaries, but we do include all of the jurisdictions that at least have a portion of their boundaries within the Great Lakes Basin. And so that would be all 8 Great Lakes states, and then the 2 provinces of Canada as well. And then, of course, the tribal and First Nation communities within that. So we have a large membership, probably about 70 members at the moment. We have a steering committee that's representative of that membership, and then some working groups that help support product development. We're guided by a regional strategy. And so once the Great Lakes Commission took over and we expanded our membership more broadly, we developed a strategy that was more representative of the regional needs. And so we have one that is was enacted last year and goes through the end of 2026, so a 3-year strategy. And so I'm going to talk about some of the work that we're doing under the 3 focus areas. So I'm going to start with the first focus area, which is information, research and information needs. And so one of the things that we're doing under this portion of the strategy is assessing and prioritizing critical information needs and research gaps. And we're hoping to do that so that we can advance European frogbit management throughout the region. So again, I threw up a little bit.ly link. So if you have your phone, you can scan that, but also you can visit the website. So one of the really awesome tools that we have on the website is this resource library, and it is a fully searchable, filterable library. It's meant to be kind of open source. So we want people to contribute to it, and we want people to take the stuff and use it. You can search it by resource type. So the resource type might be like a fact sheet, a work plan, an SOP. The topic might be ecology, biology management, control, monitoring, and then shareability. How do you need to give credit to use it, or can you just like fully adapt to this resource and use it in your own outreach activities? And so some of the more recent resources that we've added are going to be our fact sheet. And so this is just kind of a 1-pager talking about what's European frogbit, what's the collaborative, what are some of our resources. We did just put out at the very end of last year a lookalikes document, because this seems to be something that people needed some help with, especially newer resource managers, at least newer to European frogbit. And so this is something that you can pull from the website. We also have a lot of just like template social media imagery and content as well that you're welcome to pull and use. And just for fun, we add things like our paper doll of Froggy, our European frogbit collaborative mascot. And if you do some digging on the website, you can, I won't tell you how, but you can eventually find some secret Easter eggs like Meet Froggy, our mascot page. So now I'll go into our other 2 regional strategy, into our other 2 overarching goals. And so one is our goal of regional coordination and collaboration. And so under this, we have an objective of delimiting European frogbit infestations to improve our understanding of distribution in the Great Lakes region. And one of the tools I'm going to talk about is our delimitation app. And then our final strategy goal is best management planning. And then one thing that we do under this goal is we're trying to assess ongoing EFB eradication and control efforts. So understanding best management practices and hoping to inform those as well. And one of the ways that we do this is through our FrogBat, or before and after treatment tracker tool. So I'm going to start off with the delimitation app. So what is the delimitation app meant to do? Well, if you're delimiting something, you're trying to show where it is. And so that's what we're trying to do with this app. So here's our nice wetland, and you can see there's European frogbit that we have in here. Well, one of the things that we also want to know is where we looked and where we didn't find European frogbit. And so that's something that we can do with this tool. There's a couple of ways that we give users access to do this. So they can create lines, polygons, or points. So if you're creating lines and polygons, this is kind of the like quick entry. It allows you in the app, which it's a field maps app, that you can download on your phone. And this allows you to kind of track where you've surveyed. So not only where you find European frogbit, but where you surveyed, or like where you looked, because that's really important. We want to know like everywhere that was assessed for European frogbit, not just where it was found. And then there's points, and these are kind of complements to the other data sets. And this gives you a little bit more information on what the survey looked like. So if you logged on to the delimitation mapper, this is what it looks like. And so you're able to see not only the European Frogbit collaborative delimitation app information, but we also pull in other information sources as well. So you can see, here's the full kind of documented distribution of European Frogbit. Unfortunately, like I said, lots in Ontario. Now, if we zoom in on where we have data, there's a way that we can filter it. So not only can we see the presence, so we can also see absence information. We've been collecting this data since 2021, and you can see that keep finding it in more places. And so when we started in 2021, and then when we wrapped up our surveys this year, unfortunately, it's spreading is what we're showing. But this doesn't just show, again, where we're finding European Frogbit. It shows all of the places that we looked where we didn't find it. So now we can go back and we can look and better understand that spread over time, because we know, okay, in 2021, 2022, 2023, it wasn't in this location, but 2024, oh, lo and behold, there it was. We went back to that location and we found it. So since 2021, we have almost 10,000 records of surveys, and that's between the lines, points, and polygons that I mentioned earlier. And that includes over 4,000 kilometers of line surveys, and then over 1,700 hectares of polygon surveys. So we've done a lot of looking over the past 4 years. So I'm going to move on now to the Frogbit app. And so again, what this is trying to accomplish is this is trying to better understand what efficacy looks like or effectiveness of different management techniques. And so what we're doing is we are monitoring a site prior to control or management implementation, and then we are documenting some information about what management looked like, and then we're going back and we're collecting additional information after and monitoring what the site looked like post-treatment. So this is pretty easy. This is meant for kind of all managers of all training levels to be able to use. Again, it's a Field Maps app. So the tools required are pretty simple, just the ARCS Field Maps app with the Frogbit app downloaded, a 1 meter squared quadrat, so pretty big quadrat, and then a meter stick just to gauge water depth. There's a couple steps involved in this, and so enrolling kind of the area in which you're going to manage, submitting those monitoring reports, and then taking that quadrat information, and then submitting those management reports, and then going back and doing that follow-up monitoring the next year. So all in all, it's not too time intensive, but the learning potential from this is so huge.
Sorry, Samantha, you've got about 3 minutes.
Perfect. Thanks, Brandon. And so in 2024, we've had 11 organizations enroll 84 management zones, and this spans both Michigan and Wisconsin. And so this was kind of our first year of data. We had a precursor to this app, and this is the revamped, expanded version for the region. And so next year, we'll be able to look back and have those managers go back to those 84 sites and take that post-treatment monitoring data. And then we're going to really start learning about what that efficacy looks like and which management techniques are successful and which ones are maybe less successful. So you might be watching this presentation and thinking, oh, that's great. I would love to use the delimitation app. I'd love to use the Frogbit app, but I don't have an Esri account. And we get it. Esri collector accounts, which you need to collect this information, are, I think the last time I looked, are about an annual fee of $350 US. So they're kind of pricey. But we had the opportunity to provide a series of community accounts. So if you are interested in utilizing these tools, we have community accounts available. And so all you need to do is reach out to me or scan this code and fill out some information about what why you're looking for a community account. And we're happy to get you set up with one because we want to make this as accessible as possible to use these tools. And so that is all I have. If anyone has any questions, again, please go ahead and visit the website or reach out to me either at either email on the screen. Thank you.
That's fantastic. Thank you so much, Samantha. Yeah, another great presentation. Just shows the breadth of what's out there as far as organizations and different species we're trying to control and monitor, and it just, yeah, definitely shows us what's out there. So don't have any questions in the Q&A yet, but if you would like to check back in a few minutes and then answer those as they come in, I would greatly appreciate it. So again, thank you, Samantha. Take care. Thank you. Okay, so we're going to move on to the next presentation here. While that one is wrapping up, this is the third and final one for concurrent session 3 today. And this presentation is the early detection and rapid response to aquatic invasive plants. I'd like to welcome our speaker, John Goslin from CPRO. John is a technical development biologist for CPRO in the North region. In his role, he's responsible for working with water resource management firms, lake stakeholders, and government resource and regulatory agencies to best technically steward CPRO's aquatic solutions. He's involved with product development, field trials, and product support. Prior to his current role, John served as a marine science technician in the U.S. Coast Guard's Reserve. He holds a master's in agronomy from University of Florida with a focus on aquatic weed science, and a BS in environmental and resource economics from the University of New Hampshire. With that, welcome, John.
All right, thank you, Brandon. Appreciate the introduction. Yeah, I'm John Goslin, talking to you from New Hampshire here, and I'm a technical development biologist for CPRO. We are a water diagnostics and restoration company focused on development and manufacturing of aquatic technologies for water resource problems. So harmful algal blooms, invasive plants, nutrient pollution, you name it. And today I'm going to talk about early detection and rapid response specific to aquatic invasive plants. Aquatic invasive plants, they pose a major threat to our freshwater ecosystems. They can outcompete our native plants, create monocultures, and then even secondarily impact diversity of the aquatic organisms that depend on those native plants. They tend to put on a lot of biomass, more than our native plant assemblage, and at the end of the year, when they senesce and die off, they release a lot more nutrients than our native plant assemblage would, and create poor water quality conditions. And probably the most evident to the layperson would be impacts to recreational activities. Nobody wants to swim, fish, or try to paddle through a topped out mat of hydrilla, for example. These aquatic invasive plants, they're not cheap to deal with. Estimated economic health costs in the US have increased from $2 billion in the 60s all the way to $21 billion in the 2020s. And our aquatic ecosystems, they're not immune to these invasions. The reported cost in the States is $15 billion annually. And in the northeastern United States is particularly vulnerable. The cost for invaded aquatic ecosystems dominates the cost of terrestrial invasions. Ontario, also vulnerable to these types of invasions. You have similar geography to the northeastern US. 2019 Invasive Species Center estimated that potential impacts of invasive species may be as high as 3.6 billion per year just in Ontario. And I suspect that invaded aquatic ecosystems would be a large portion of that cost and effort. This would not be an official EDRR talk without mention of the invasion curve, which is basically a model that shows control costs over time and on the y-axis, you see area infested. So if you look at the bottom left there, that's prevention, right? There is a cost associated with preventing invasive species or invasive plants from getting into your water bodies, but it's absolutely minimal compared to what can happen. As you move down that x-axis across time, if you do get an invasive plant, it's best to act quickly, detect it, and rapidly control it. That cost of control may seem high in the moment, but compared to long-term management, you're a lot better off going for eradication quickly. If time passes, managers fail to act quickly, you can move further along that curve. So more areas infested, more time passes, you may be in a containment strategy at that point where costs are higher and likelihood of eradication is very, very low. If more time passes without action, you allow that invasive plant to become widespread and abundant. Eradication becomes close to impossible, and you end up in this asset-based protection, long-term management strategy, which is extremely expensive and really only goes after the problem in your high-use areas, marinas, boat ramps, public beaches, for example. So you want to stay away from getting to that point on the invasion curve. With that invasion curve in mind, early detection, rapid response are essential strategies for minimizing ecological and economic impacts of invasive plants. And if done right, you can increase the likelihood of eradication of that invasive. So a lot better to be looking for it. You find that sprig of milfoil on the boat ramp, and act quickly, pull any plants that might have established, right around that boat ramp versus waiting till the problem is in your face and, flowering throughout the whole littoral zone. Environmental agencies recognize the importance of EDRR and provide funding through government grants, private sector support. So in a water body scenario, this could be a sailing club or a marina, a waterfront restaurant or a waterfront camp that might provide funding for EDRR, or nonprofit organizations such as professional industry societies, things like that might be able to help. Local example, the Invasive Species Center provides the Invasive Species Action Fund from the Ministry of Natural Resources. So if you're a water body stakeholder, I would encourage you to familiarize yourself with what's needed to apply for funding before you encounter an aquatic invasive species. In the state, this is a perfect example of some of this invasive species rapid response funding going to work right now. The Ontario government invested $500,000 recently into the Invasive Species Center to mobilize a rapid response plan against 2 high-risk aquatic invasive species, hydrilla and water soldier, that have gotten into Hillman Marsh and Lake Simcoe. And we have rapid response funding here in the States too, mostly through our U.S. Fish and Wildlife Service Rapid Response Fund or Great Lakes Restoration Initiative funding. We also get technical guidance and support through our Aquatic Nuisance Species Task Force and regional task forces, as well as our industry professional societies like the Aquatic Plant Management Society and regional chapters, or the North American Lake Management Society. Aside from funding, regulation is another important part of EDRR. For example, the Ontario government has regulated 10 species and 4 groups of species to prevent, control, and reduce their spread. And as of 2024, they are prohibited, meaning it's illegal to import, possess, transport, or release these species anywhere in Ontario. And these are your bad actors in Ontario. Many of you probably familiar with water soldier or European water chestnut. Hydrilla, maybe not so much. That's a new one, only in one water body. And, I think you all are working diligently to keep it that way. There are also additional species that are restricted, your Asian water milfoils, fanworts, meaning that you can't bring them into parks, and it's illegal to import or release them anywhere in Ontario. From an individual perspective, the Clean, Drain, Dry, or Dispose initiative is extremely important. So clean those aquatic plants off your trailer bunks, the wheels, propellers, drain out your bilges or wet wells, so things like zebra mussel veligers can't survive and be transported to the next water body. And any unwanted aquatic vegetation that you find, make sure it's disposed of in the appropriate areas. So things like waterfowl can't take them to the next water body. And keep in mind, I think most boaters do follow these laws to prevent spread of AIS, but it only takes one to introduce a new infestation. So outreach, education on this initiative is really important. Beyond regulation and funding, those two things are not going to protect our water resources alone. We do need community support. And this can come from a variety of places. For example, lake associations play a major role in EDRR. So lake association leadership should be educating their members on what to look for. You're not going to find invasive species if you're not looking for them. You got to know how to report them. At the minimum, a photo and a location should be recorded, and who to communicate to, whether it's that lake association leadership, but eventually that report needs to make its way to a local regulatory agency. Other roles that lake associations can play in EDRR can proactively find sources of funding for AIS work, should you need that in the future. Potentially hire a consultant to conduct an assessment of the lake and continuous monitoring and management if need be. Look into what it takes to obtain a permit for AIS management, and even assist with implementation or management actions or monitoring efforts. You don't have to be in a lake association to do your part. The Ontario Invasive Plant Council recognized this and created the Early Detection Rapid Response Network in conjunction with the Invasive Species Center. And that program covered 5 different regions and engaged over 16,000 people. So training and equipping them with skills and resources needed to detect and reduce invasive plants. And then those volunteers take their knowledge and they spread it far and wide. Your everyday person can use technology to report aquatic invasive plants. So a couple examples: iNaturalist, that's a worldwide app for reporting these infestations, or maybe even a little better for us would be the EDD maps. This is specific to North America. And all you have to do is have the app, you snap a photo to report that invasive species. It'll be time-stamped and geolocated. Or simply just call the invading species hotline down on the bottom left of the screen there. While we're looking for these invasive plants, it's important to remember not everything's a weed. Our native aquatic plants are a vital part of our healthy lake ecosystems. And this is where professional assistance comes into play, or can. There's several monitoring techniques that we use to assess the plant assemblage in a lake. We can use local volunteers, like the Lake Association example, as long as they're trained properly. There are organizations out there that provide funding for boat ramp stewards. So folks that man the boat ramp and take a look at these vectors for invasion, like boats or fishing gear, and make sure that they don't have plant fragments on them. And then annual macrophyte surveys can be done So point intercept rake toss survey. You can use an underwater boat mounted camera and patrol areas where invasive species are the most likely to be introduced. Or simply look for them via scuba divers, swim in transects. The first talk in this session did a great job at going over some more of these advanced techniques. So I won't spend much time here, but we can use environmental DNA traces now to determine if there's an invasive species in our water body. We can use satellite imagery or drones to detect invasive species, and even artificial intelligence. They can analyze large data sets and provide guidance on where an invasive plant is most likely to be found next. Prioritize our early detection efforts. We talked about the early detection part of EDRR. Let's cover a little bit of the rapid response part of it. This is kind of the basics of a plan. You have your early detection and, of course, confirmation that that invasive plant is what the person that found it thinks it is. Appropriate notification to the right people and immediate containment. And then we get on to the assessment phase. You know, where is that plant in the water body? How widespread is it? And then the planning of your rapid response. And of course, implementation. Ideally, that rapid response plan is already in place and you can implement quickly. Once you've implemented the plan, monitor the effectiveness. If there are any non-target impacts, go ahead and initiate restoration efforts afterwards. A few best practices for rapid intervention. Pre-planning is really important. Develop those action plans in advance of a threat being introduced to the water body. Create a quick response team. So this could be a committee within your lake association. It could be a consultant, or it could be a local government agency team that you've partnered with. And then collaborate with your local, national, and maybe even international organizations to leverage resources. We know that not every lake association can do all these things, but there are groups out there that can provide help. An effective response is a coordinated response. So, you know, we went through the plan: detect, assess, plan, implement, monitor, and restore. But things change as you're implementing these plans. So adaptive management's important. And as things change, we really need to make sure we're communicating any changes with all the partners that are involved. There are always challenges, limited resources, funding and manpower, public awareness, engaging the community, letting them know what to look for, what might be coming next, and data gaps, not having complete bathymetry for your lake, or not having up-to-date macrophyte surveys. So these are all topics to think about. Act now before an invasion occurs. And I'm going to leave you with a great example of EDRR that's happening right now. Hydrilla was found in Ontario and Hillman Marsh, the first infestation in Canada. And I know Dr. Rooney covered this in detail, but the basics are that the University of Waterloo Wetland Lab discovered it. There are many partners that are containing the spread, evaluating the extent of it, and developing plans for control. But they acted quickly. They immediately closed the west cell of the marsh to stop spread. And they're currently doing their due diligence to investigate different control options and ideally execute the option with the best technical fit as soon as possible, maybe even next spring. So stay tuned on that. I'm sure Dr. Rainey will have more information for you over the winter and next spring. But with that, thank you for your attention, and I'll take any questions.
Thanks very much, John. Fantastic presentation. Thank you for your time today. We don't currently have any questions in the Q&A as of yet, but if you wouldn't mind checking in a few minutes and see if there's something there and you can pop in and answer, that'd be greatly appreciated. So once again, thank you. Thank you, John, for your presentation. Appreciate your time today. Thank you. With that, I think we're a couple minutes, 2 minutes early, so that's great. We'll move into a break now, if I'm not mistaken. Yeah, we've got a break for 10 minutes or so, and we'll be back with the last 3 presentations of the day about 3:20 today. Thanks, everybody.